Hello and welcome to AP Calculus Section 5.4b Homework Solutions. You want to open up to page 346. We're going to work 75 through 91 odd. We are getting so close to the end of this section. I was able to get 3 of the solutions on the board here, so I'll talk through those and then I'll work the rest of them. So 75, we're to integrate e to the 5x times 5 dx. So usually, unless it's just e to the x, it's going to involve a u substitution. So if we let u be 5x, then du is 5 dx. That du is just sitting right in the problem here. So we can rewrite this in terms of u as e to the u, substituting 5x for u, du. Okay, so the antiderivative of e to the u is e to the u, so e to the u plus c, and then we substitute back in the u, which is 5x, and you can take the derivative of that and get right back to this. All right, number 77 is a definite integral, so we have to plug these numbers in on the integrand. But that's e to the minus 2x dx. So if we let u be negative 2x, then du will be minus 2 dx. We want it to just be dx here. So if we divide both sides by negative 2, I'd have a negative 1/2 du is equal to dx. And then I can rewrite the integral in terms of u as negative 1/2, and then we're integrating 0 to 1 of e to the u du, right? That'd be e to the minus 2x is what we have here, and then du is equal to dx because we brought that negative 1/2 out front. So the antiderivative of e to the u is e to the u, so I'd have negative 1/2 e to the u. No plus c because this is a definite integral. And so we have negative 1/2 e to the minus 2x when we substitute back in for u. We're evaluating that from 0 to 1. All right, so I'm going to have negative 1/2 e to the minus 2 times 1, so that's negative 2 minus negative 1/2 e to the 0. E to the 0 is just 1, right? 2 negatives make a plus, so it's going to be negative 1/2 e to the minus 2 plus 1/2. All right, and that is fine with me. You could also put that in your calculator and get the decimal answer for that, which I believe is 0.4323, and the back of the book may give you that. All right, number 79, we have e to the minus x over 1 plus e to the minus x. Now, you want to choose the bottom to be u because we can't handle du being on bottom. So if we let u be 1 plus e to the minus x, then du is minus e to the minus x, right? It's e to the minus x times negative 1. We want it to just be e to the minus x dx. All right, I forgot the dx there. Okay, and so if we divide both sides by negative 1, then we would have minus du is equal to positive e to the minus x dx, and that's what we want. So now we bring our minus out front. We have du over u. So now we're going back earlier in the chapter where we integrated du over u, and you know that's minus the natural log, because the minus is out front, of the absolute value of u plus c. So we'd have minus the natural log of 1 plus e to the minus x, absolute value of that, plus c. You take the derivative of that, and you can see you can get right back to this because it's going to be 1 over this quantity times the derivative of this quantity, which is minus e to the minus x, and then the negative out front would cancel, and then you'd be back to the original. So you always want to check when you can. Okay, let's look at number 81. So 81, we're integrating from 1 to 3, e to the 3 over x divided by x squared. Now I hope you can see that if you let u be 3 over x, that's the same as 3x to the minus 1, right? So du is going to be minus 3x to the minus 2, and that's just minus 3 over x squared dx. What I need it to be is 1 over x squared dx. Okay, so if I multiply both sides by negative 1/3, I would just have 1 over x squared dx, and that is sitting right there. You don't see the 1, but it's implied that there is a 1 there, dx. So I could rewrite this as negative 1/3, and then it would just be e to the u du. So go through that in your head. E to the 3 over x, and then du again is 1 over x squared. The negative 1/3 out front fixes the issue of the coefficient. So that's going to be negative 1/3 e to the u plus c. So that's negative 1/3 e to the 3 over x. And it's not plus c, I'm sorry about that, because it's a definite integral. So 1 to 3, evaluated from 1 to 3. So we have 3 over x now. So that's going to be negative 1/3 e to the 3 over 3, which is 1, minus negative 1/3 e cubed. So that's going to be negative 1/3 e plus 1/3 e cubed. And that is fine with me. I think the book factors out a 1/3 or a negative 1/3, but that doesn't make things any better in my opinion, so I'm totally fine with that. All right, that one was pretty fancy. So number 83. Feel like the rest of them get easier for this assignment. So we have e to the x and the square root of 1 minus e to the x dx. So let's let u be 1 minus e to the x. And then du is going to be e to the minus e to the x dx. And then minus du, we want it to be e to the x dx. Right? So we want it to be e to the x times dx. So minus du is e to the x dx. And we can rewrite this integral now with a negative out front, that negative, and it would be just the square root of u du. All right, so that's going to be the negative out front, u to the 1/2 du. So that would be negative, and then it would be u to the 3/2, but I need a 2/3 out front. All right, so that'd be negative 2/3 times 1 minus e to the x to the 3/2 power. And then we can't forget the plus c. All right, so let's just take the derivative of that in our head. 3/2 times negative 2/3 would be negative 1 times 1 minus e to the x to the 1/2 times negative e to the x. So the negatives would cancel. You have to the 1/2 power. So yeah, that does work. If you want to do it on paper instead of your head, that's totally fine, but I can see it in my head that indeed does work. All right, we're moving right along. Okay, 85. So 85, we have e to the x plus e to the minus x over e to the x minus e to the minus x. So again, you want to pick u to be in the denominator, because that'll put du in the numerator. So if we let u be e to the x minus e to the minus x, derivative of that's going to be e to the x, and then minus e to the minus x, but two minuses makes a plus. And goodness, that's exactly what we have on top. So then we can rewrite that integral as just du over u. I didn't even have to, because negative e to the minus x would be plus e to the minus x. So wow, so that's just going to be the natural log of the absolute value of u plus c. So that's the natural log of the absolute value of e to the x minus e to the minus x plus c. I'm just going to check that in my head. That'd be 1 over e to the x minus e to the minus x times e to the x plus e to the minus x. And that's exactly what we need it to be. So boom, 85 is complete. 87, we have 5 minus e to the x over e to the 2x. I know some years I do have to work this problem because students they forget. If I've just got a single entity in the bottom, I want to rewrite this integral as 5 over e to the 2x minus e to the x over e to the 2x. I don't want to go into u substitution if I don't have to. All right, and that would be dx. So that's going to be 5e to the minus 2x, and then x minus 2x. Remember, you subtract. X minus 2x would be minus e to the minus x. All right, now I'm going to do these separately. So, you can do a u substitution. We could let u be negative 2x here and let u be negative x here, but you might be able to just kind of do this in your head. So the antiderivative for e to the minus 2x, we have the 5 out front. It's going to be 1/2 e to the minus 2x, so negative 1/2. So what I would do is this is e to the minus 2x times negative 2, and negative 2 times negative 1/2 is going to be just 1. So I'm doing this in my head instead of a u substitution because it's fairly simple. And on this one, it's going to be minus e to the minus x, right? The antiderivative of e to the minus x, but you've got a minus out front. So that would be negative 5/2 e to the minus 2x plus e to the minus x, and then plus c. Now if you want to go through a u substitution on each of those, you can if you have trouble seeing it, but what I did is I just kind of took the antiderivative in my head and then took the derivative to make sure I could get back to this, and that works for me. Okay, so again, take the derivative of this. It's going to be e to the minus 2x times negative 2. All right, so negative 2 times negative 5/2 would be 5, and then you'd have e to the minus 2x, and then minus e to the minus x would be the derivative of e to the minus x, which is there. So there you go, that works. Let's see if I can fit 89 on here in this area. I'm probably should erase, but we're going to give it a go. So 89, we have e to the sine pi x times cosine pi x dx. So I hope you can see, if you let u be sine pi x, then du is almost cosine pi x dx. So du then is going to be cosine pi x times pi. Remember, you've got to times the derivative of the angle. So it's going to be pi cosine pi x dx. Okay, I need it to just be cosine pi x dx. So if I divide both sides by pi, I'd have 1 over pi du is equal to cosine pi x dx. So I can rewrite the integral as 1 over pi times e to the u du. All right, du is cosine, then that's it. So that's going to be 1 over pi times e to the u plus c. And that's going to be 1 over pi times e to the sine pi x plus c. All right, I'm going to take the derivative in my head. That's going to be 1 over pi times e to the sine pi x times the derivative of sine pi x, which is pi cosine pi x. The pi and the 1 over pi cancel, and you are good to go. All right, so I was able to barely squeeze 89 in there. And here we go for the last homework problem that is not a test review for 5.1 to 5.4. So we got number 91. That's e to the minus x times tangent e to the minus x dx. Okay, so you can see if you let u be e to the minus x, then du is minus e to the minus x dx. That's almost what you need. What do you need? You need e to the minus x dx. Right, that's what you need it to be. So all I have to do is divide both sides by a -1. So I can rewrite this integral as the negative out front, and then we would have tangent u du. Now you have to remember, back from, I believe, section 5.1, what's the antiderivative of tangent u? Well, this is going to be minus, and then minus the natural log of the absolute value of cosine u plus c, right? Okay, that is something that you have to memorize, those trig antiderivatives for the test. Well, minus minus would make a plus, so that's the natural log of the absolute value of cosine e to the minus x plus c. And then you could take the derivative of that. It's going to be 1 over cosine e to the minus x times sine e to the minus x times minus e to the minus x. And that is going to take care of everything. You'd end up with the sine over cosine, which would give you the tangent, and e to the minus x. All right, that does it for this homework solutions video, and I will talk to you on the test review video for this section.